it's 6:30. Are we good to go? Nodding heads. Welcome everyone to the Lane County Master Gardeners Association seminar on soil testing methods and report interpretation for gardeners. My name is Stephen Oldfield. I'm a Master Gardener in Lane County, and I'm here to introduce this evening's speakers. Just as an aside, has anyone ever tried to recruit speakers for a seminar? I'm still waiting to hear back from people I contacted about 2 years ago, but the OSU Soil Lab is different. I think it took 20 minutes from sending the email and I had a response in my inbox. That was down to Kristin McAdow, the lab manager at the OSU Soil Health Lab, where she manages everyday business operations of the lab, assists in teaching a soil/field lab course, and serves as a soil health resource for the community. She also responds promptly to email. Kristin holds a BS in Botany and Conservation Biology and an MS in Soil Science from the University of Wisconsin-Madison. Her interest in soil science began while she was working for CSA Farms and the university's student farm during her college summers. After completing her MS in 2020, she left her home state and bike toured Washington and Oregon, helping at farms along the way to learn more about small-scale agriculture in the Pacific Northwest. That adventure led to a position at the Soil Health Lab, where she enjoys teaching students and sharing information about the lab's services with customers. The person who recommended that I contact Kristin was Erica Chernoh, Assistant Professor of Practice at OSU in the Department of Horticulture. Anyone who's contacted the OSU Extension office in Eugene since 2016 is probably familiar with Erica because she oversees the Master Gardener program there. Erica interned on an organic farm as an undergrad and loved growing her own food, which really got her into food-related issues. Her main focus is organic and conventional production systems of hazelnuts, fruit trees, berries, and small fruits. She has a particular interest in strawberries, but is basically interested in anything edible. This morning, Erica was interpreting models for codling moth control. This evening, she'll be interpreting soil test results. But first, let's hand over to Kristin to start us off.
Thanks for the introduction. I'm going to share my screen. Let's see. Okay, does that look okay? Can see my slides? All right, great. Well, thanks. Yeah, so I'm going to be talking about the soil testing methods part, and Erica will be talking about report interpretation. Here's an outline of what I'll be talking about. So I'll give a little overview on who Soil Health Lab is, why you should test your soil, how to test your soil using kind of like a 10-step plan breakdown. And then I'll touch a little bit on soil health, since we are the Soil Health Lab. I'll talk about how we might differ from other labs and when you would choose a soil health assessment as opposed to maybe a basic nutrient analysis. And then if there's time, I'll talk a little bit more specifically about the analyses that we offer. Okay, so we are the Soil Health Lab. You might have been familiar with us as the Central Analytical Lab. We recently changed our name to better reflect our mission and our specialty in soil health analyses. We're made up of a team, got the lab director, myself, the lab manager, a faculty research assistant, and a team of undergrad technicians. In addition to analyzing soil material, we also analyze plant and compost samples. We serve a large array of customers, so gardeners like yourselves, as well as growers and the research community. We're unique from other labs in that we are a service and teaching lab. So not only are we serving the community, but we're also providing a teaching space for undergraduates as well as grad students. Many grad students will perform their project analyses in our lab. And then lastly, we also offer a summer field and lab graduate course, and there's a couple pictures up here from the field portion of that class. Okay, so why should I test my soil? Couple different reasons I've listed here. So one might be that you want to add different applications of fertilizer prior to planting this year. Another reason might be you noticed a deficiency or toxicity symptoms in some of your samples. And lastly, maybe you're interested in soil health and you're making some management changes, and you might want to see how those management changes affect soil health. I also have, throughout my slides, I have a couple chat box questions, so you can plug it into the chat. The first one is, what is your reason for soil testing this year? Okay, so how do I test my soil? I've got this 10-step plan here. I'm going to break it. I'm not going to go through each one right now, but over the course of the next slides, I'll go into each one of these steps. I've highlighted in yellow areas where the Soil Health Lab contributes to this 10-step process. I think a lot of folks think that we will help with each step of the way. I wish we had the capacity to do that, but luckily we have support from the Plant Clinic and OSU Extension publications. So together we're able to complete this 10-step plan, but the Soil Health Lab is more of a middle character. And that's further illustrated here. So when you start trying to figure out what kind of test you want and think about your sampling plan, that's where you contact the Plant Clinic and maybe look at some of your OSU Extension publications. Once you've done that, then you can pop over to the OSU Soil Health Lab, and that's where we will generate a report for you. And then output of the report would come from us, and then interpretation and management would come from the Plant Clinic and OSU Extension publications. Okay, so step one, determine your reason for testing. So think about reasons. So why you would want to test your garden, think about your experience over the past year and what you want to know. Are you going to be making any big management changes this year? And thinking more specifically, are these measurable changes? And I'll talk about that in a moment. Some of your main resources for this would be your Plant Clinic. I've got a contact here, and maybe there'll be a phone number in the chat we can put in. And then OSU Extension publications. One of the best would be the Soil Test Interpretation Guide. So I've got a link down over here. Step two would be to create your sampling plan. So think about how many soil samples you want to collect, which beds to collect from. Remember that one sample should always be a composite of many soil samples. So for example, if you had some deficiency symptoms in your tomatoes and you want to test the soil in your tomato bed, you wouldn't want to take just one sample from that bed. You'd want to take a bunch of samples from that bed and composite them into one sample that's representative of that entire bed area. Resources to help you with creating your sampling plan would be the Plant Clinic. There's some OSU Extension publications, one of the most notable, Guide to Collecting Soil Samples for Farms and Gardens. And then you also might just want to get some aerial views of your garden. So you can use Google Maps. I like using Web Soil Survey. So this is kind of an online soil map resource. I've got a picture of it over here on the right. And this is an aerial view of my garden last year. And you can see that there's these different designations with codes. And then you can pop over to the map legend and see that I've got a lot of Jory silty clay loams in this area. So that's a very helpful resource. Chat box question, what tools do you use for creating your sampling plan? Do you have any favorites that you'd like to share that I didn't mention? Okay, step three, that would be identify the test you need. So this falls back on your reason for testing and considering actionable items that could result from a test. And what I mean by that is think about, if you got a pH and buffer pH test result, then you would use that, for your lime applications, or if you did micronutrient or organic matter testing, then that could help with your fertilization plan. So think about what you want to know and what measurable analyses you can do. Resources for this would be the Plant Clinic, Extension publications, and we have a page on our website that I'm going to pop over to here. So this is just a screenshot. This is our interpreting results webpage. You could take a look at what some of the reports would look like, so you know what to expect. These are of a couple of our different packages, and you can peek and see what data they would contain and in what format the output would be. Step 4 is to connect with the testing lab. There's a great article or extension publication that I often refer folks to. This is the Analytical Lab Serving Oregon publication, and it's got a great chart that has all of these columns and labs listed. This is another screenshot from that publication. So you can look at all the labs and then go to these different categories like soil testing, and then there's subcategories. You could go to subcategory 3 and see that both of these labs listed here test for heavy metals, but they do not test for pesticides and other chemicals. So this is helpful in figuring out which lab you'd like to select for your needs. Okay, important questions to ask your testing lab. Just a couple here. So make sure you get a list of analyses that they offer and that they're very clear on what the analysis fee per sample is. Make sure there's clarity around turnaround time and the date you need results by. Definitely want to confirm that you are getting results when you need them, especially if you have certain plans for different management activities. Another thing that you could ask them would be about their data quality assurance. So a lot of labs will participate in these proficiency testing programs. So we've got the symbol of one here. NAPT is one of those programs. A bunch of labs will send their, or actually get sent soils from this testing program. We all test those soils for different analyses, and then we give our results back to NAPT, and NAPT will look and see what these values from the analyses that you did are, and can let a lab know if they're not performing well in a certain analysis or they're not giving good quality. So that's a great way to make sure you're getting good data. You also want to ask for instructions on submitting samples and any special sample collection and handling considerations they might have. And if you go to our webpage, we've got our testing services here and some information on how to collect and submit a sample, as well as our fees per analysis. Some common packages that we would offer for gardeners. We've got a basic and advanced packages. So these are some of our macronutrients in here: total carbon, nitrogen, and organic matter. And then our advanced package would have more of your micronutrients included. And then a basic soil health assessment would have pH, texture, your carbon, nitrogen, organic matter, a physical property. So we got what aggregate stability, and then a biological property of microbial respiration. A couple other packages. So we also offer a manure compost analysis. I should have put on here, we have a plant tissue analysis, and then also a heavy metal soil analysis. So we can test for heavy metals. Unfortunately, we cannot test for organic contaminants. Just something to note, because I think Erica mentioned there might have been a couple of folks looking for dioxin testing, and we do not do that, but I would suggest looking at the Analytical Lab Serving Oregon article. Lastly, we also offer kind of a buffet style pick your own analysis. So Say you're just looking to get your buffer pH because you want to lime your soils this year, you could also just select that one analysis and we can give you that result as well. Okay, so step 5 then is to collect your sample. After you've connected with your testing lab, think about if your sampling plan needed to be adjusted based on what you learned from that lab. So maybe you need to adjust number of samples or some other part of your plan. You also want to make sure that you're collecting the appropriate volume of soil that they need. You don't want to have to send extra soil if you send too little, so make sure there's clarity on that. And then also, again, following any special collection and handling instructions. A little caution here. So improper soil collection can result in erroneous lab data and can pose a challenge for year-to-year report comparison. So definitely want to make sure you're being consistent with your sampling, especially if you're doing soil health testing. Make sure you're going to the same depth, keeping a similar sampling plan so you can compare data from year to year. Step 6 is to submit the sample to the lab. So make sure you get instructions on drop-off and mailing for your lab. Provide them with your contact info and the analyses you'd like, as well as including payment if appropriate. So this is just a picture of, we have a little drop box outside our door and you can bring your soils, and then also we have submission forms to fill out. So you can learn more about how to collect and submit a sample again at our testing services webpage. We have this one-page document, try to keep it quick and easy and straightforward. Some highlights from this document on submitting samples specifically to our lab would be to prepare 2 to 4 cups of soil sample. You want to store your soil in a labeled plastic bag, put your name, maybe which field it came from, and the date. We also want to keep samples cool until analysis if you've selected a nitrogen or microbial analysis. So these analyses or microbes are really sensitive to changes in temperature as well as moisture. So we want to keep them in a plastic bag, keep them in the refrigerator after you collect, maybe put them on ice if you're sending them during the summer to our lab, or pack them with insulating material. You'll also fill out a sample submission form when you're sending samples to our lab. This just has a space for you to give contact info, the analyses you want, and your timeline. We can offer mail or drop off for samples with their submission form, and payment actually occurs after the report is received. So don't send your check to us in the mail. We don't handle payment at our lab. The business office does for this space. Step 7 is the worst step, just waiting until your sample is processed. So this can vary by your submission type, number of samples, the package you select, and especially the time of year during some of the busy testing times. So make sure, again, clarity with turnaround times with your lab. Caution or note, soil health analyses take longer to complete than basic nutrient analyses. This is kind of the nature of soil health assessments, and hopefully I can highlight that a little later here, but yeah, just be aware that that will take longer than your traditional NPK test. Step 8 is receive that report. Again, we will send a report and invoice via email, and you pay with the to the contact at the bottom of the invoice. And then step 9 and 10 is more of Erica's talk and realm. So again, just to emphasize, we don't provide report interpretation, but we can offer guidance with any questions you have about the specific analyses we've offered, any report terminology. So if you have a question about the units we used or some of the technical details, if you want to check in and maybe one of the results looked odd and you want to confirm the data quality, check in with your lab. And then also we can offer interpretation resources. So we have resources on our interpreting results webpage. And then again, you can go back to that soil test interpretation guide. Chat box question here is, what resources have you found most helpful for your report interpretation? And you can share those in the chat. Okay, now diving into more of the soil health aspects, so kind of looking at these holistic assessments. I'm going to highlight how the Soil Health Lab might differ from traditional testing labs using a kind of silly or kind of fun metaphor. So thinking of the soil body as being somewhat similar to our human body. So with the human body, you can measure all of these chemical, physical, and biological properties of the human body, and soil body is also a living system. And when we're talking about what some of the more traditional testing labs would do, that would be more the realm of soil fertility. So this would be looking at your soil pH, your lime requirement, and looking at your nutrients in the soil. Sometimes that's the perfect test for you. You know, if you're just doing looking for information on how to fertilize or lime, then soil fertility tests would be great. That would be our Western, Eastern, basic, or advanced soil packages. If you are interested in kind of looking at more of a holistic assessment, and I'll talk about in the next slide when you would test for soil health, then you would be getting more of these other properties of the soil. So some of these physical properties like aggregate stability, how well are your aggregates in your soil holding up to different rain events and reducing erosion, maybe texture, looking at your sand, silt, clay, that can impact your fertility, as well as how water moves through the system. And then also looking at some biological properties like respiration, biomass, and active carbon. Microbes are our masters of nutrient cycling, so interesting to get a whole picture of what's going on in the soil, or to the extent that we can measure right now. So when would you choose a soil health assessment? When would that be a good fit for you? They're only valuable when you know you're going to sample for multiple years in a consistent way. So that's when your data starts to have meaning, when you can compare data from the previous year to the current, to the following. So make sure if you choose a soil health assessment that you plan to sample for multiple years. Soil health indicators are also sensitive to changes in management. So if you had a big management change that you were undergoing in your garden this year, and you wanted to see the effect of that on soil health, these indicators might be able to show any changes that are occurring. And lastly, I think I was going to talk a little bit about some of the soil analyses and more of like the nitty-gritty details. If you go to our webpage under the methods and equipment section, you can click this little button down here, and that'll take you to our very dense standard operating procedures. So if that's of interest, you can get into those details. Would it be good for me to pause here or continue on for the next like 5 to 6 minutes?
Go ahead and continue on.
Okay, great. Okay, so I'm going to break it down into chemical, physical, and biological analyses we offer, and I'll try to give just a brief overview. So we've got our soil pH and our electrical conductivity. Those are 2 analyses we offer. Soil pH, you're looking at your acidity, your alkalinity, and your electrical conductivity, you're looking at your salt. So we put equal parts of soil to water in these are called Falcon tubes, and then we measure the pH or electrical conductivity with a probe. It's kind of like measuring a puddle, essentially. We also offer the lime requirement. So that's when you'll measure your soil pH, and then we add this, it's called the Sakura buffer. It's set to pH 7.7. We add that to your soil, we shake it up, then we measure the pH again, and we see how resistant your soil was to change to this new pH. So you had a soil at pH 5, we introduced a pH 7 buffer, and so now we see how much acidity is stored in your soil and how resistant the sample is to change. One note on this, I think the soil test interpretation guide uses the SMP buffer as a reference for calculating your lime requirements. The SMP buffer, I think it's not the safest for lab technicians, and so there's been a transition to Socorro buffer, and that's because of some work from Dr. Amber Moore and Carl Makepeace. And so if you're interested in doing lime requirement calculations with the Socorro buffer, I have a link here to that extension publication or technical note. We also offer the total carbon and nitrogen analysis. So we pop your sample down this really hot tube, and it combusts, and we can determine total carbon. And then there's a series of reduction and drying tubes, and by thermal conductivity detection, we can determine nitrogen and sulfur as well. I wanted to talk a little bit about what a soil extraction is and what that looks like in the lab. So this is soil extractions are used to determine your plant available nutrients. So the steps for that would be to weigh out your soil, add your extracting solution. So this is your solution that's going to pull your plant available nutrients out of the soil. Then you would shake the sample up, so mix that soil and extracting solution together. You would filter out the soil, collecting the filtered solution. So this is kind of like making a pour over coffee. You add in, you want to kind of filter out all your grounds or your soil and leave your solution or your extract, kind of like your coffee is your remaining sample. And then we take that extract and we run it through different lab equipment. We've got a spectrophotometer and an ICP, and that would be the tool that would quantify the nutrient content. So this is kind of the extraction sequence. We also offer some physical analyses. So we've got texture by hydrometer. We add your soil to this column, and we add a dispersing agent. So your sand, silt, and clay are all running about in the column, and then each of these particles has a different size and mass, and so they'll fall at different rates when we agitate the sample, and we can measure those falls by water displacement using a hydrometer. So if you've ever done beer making, I think you also use a hydrometer, but ours is calibrated for soil. We offer aggregate stability as well. This is using this contraption, the Cornell infiltrometer it's called. We add your soil to this sieve, and then we kind of make it rain over the sample, and then we see how much of the soil maintained its aggregate structure and how much washed through the sieve and landed in the filter paper. So this is a very relaxing analysis. We also do available water holding capacity using a pressure plate system. So we've got this air compressor and forcing air into each of these. They're called pressure bombs, or you can call them chambers. And we set them to different bars of pressure. And at these different bars of pressure, water is held differently in the soil. So we have one chamber that holds soil water at a maximum, or plant available water at a maximum, and then another chamber holds it at a minimum. And then with the difference, we can determine how much, what your plant available water holding capacity would be. Popping into the biological analyses, we offer active carbon. So this is an indicator of soils rich in microbe food. So we thought, our lab director and his student Isabel Christie are doing some research that might change the way we think about active carbon, but I won't touch on that too much. This picture just came from Isabel's research. So active carbon, we add this oxidizing solution, potassium permanganate, to the soil, and we're able to see the percent of carbon that was oxidized, or the percent of microbe food, you could say, that's oxidized, and it comes out as this nice color gradient if you have increasing amounts of carbon here. So we use that color as an indicator of the percent carbon or active carbon in the soil. We offer potentially mineralizable nitrogen. So we have these little cups that have kind of ideal microbe environment, ideal conditions of moisture and temperature. We let them sit for 28 days, and we're able to measure the amount of organic nitrogen that's converted to plant available nitrogen. We also offer organic matter by loss on ignition. So we basically burn all of the carbon off your samples. You can see some of our burn marks coming out of the muffle furnace. This would just give you percent organic matter. All right, and to wrap up here with some of our biological analyses, we also offer microbial respiration. So this is an indicator of microbial activity by CO2 production. Basically, it's similar to potentially mineralizable nitrogen, in that we have these cups with soil, and we kind of have ideal water conditions. And then this Picaro tubing, that's what this machine is called, comes through and measures the CO2 production in this closed environment. And we measure that over a series of hours, and we can see how much CO2 the microbes are producing and use that as an activity indicator. And then lastly, we can also measure the bulk biomass of the microbes in your soil as indicated by total carbon. And this is our machine that does that. I think that is all I have. I've got contact information here, who you can ship samples to or where, and then further contact. And I will put my slides into the chat box so that you can click on some of these links as you'd like. All right. Stop share. Let's see. Great.
Okay, thank you, Kristin. That's actually quite informative. So now I'm going to talk about soil test interpretation. So what do you do once you take a soil test and get the results back? Okay, so I'm going to go over kind of report formatting, interpretation guides, and then interpret some results, go through what that means. So generally when doing a soil test, you don't need to test for everything, although I do say if it's the first time you're testing your garden or you haven't done a soil test in like 10 years, go ahead and get a complete soil test. And Kristin kind of went through what that package means. Generally that's like your macronutrients, soil pH, and then maybe one or two other things. But if you're doing soil tests regularly, and we do recommend like every 3 years or so you get your soils tested, then you essentially really want to test for soil pH. Soil pH is probably the most important thing you can test for here, especially here in Western Oregon, where we get a lot of rain, and those rains tend to leach a lot of base cations out of the soil, and so we end up with these really acid soils here. So testing your soil pH to make sure your pH is within range is probably one of the most important things you can test for. Testing for phosphorus, make sure that you request the Bray P1 test. And then we recommend calcium, magnesium, and potassium as well for your macronutrients. You could also consider doing boron. I know for certain crops, boron is really important for strawberries, for fruit production, and hazelnuts, for nut fill. So we do generally recommend boron testing for those crops. And then organic matter or soil carbon testing can also be really important indicator of soil health. And it's also great for long-term monitoring to be able to kind of compare your soil tests every couple of years to see if organic matter is increasing or decreasing in the soil. These things on the right-hand side, they'll give you really interesting information, but they aren't essential. Nitrogen is really hard to test for. Testing isn't all, it can be quite variable, but if you're interested, you can do ammonium or mineralizable nitrogen. Nitrate's really hard because nitrate leaches out of the soil. So generally, if you're going to do a nitrate test, you want to do it at the end of the season post-harvest, but before like the onslaught of winter rains as well. Sulfate, which again can be hard to test for in soils. We often recommend tissue testing for sulfur. You can also look at percent base saturation, cation exchange capacity. You can look at nutrient ratios. Some soil tests will tell you the texture of your soil. And then, of course, there are these like soil health tests and soil health scores that can be tested for as well. But at a bare minimum, it's good to know your pH, your phosphorus, and your macronutrients as well. So soil test reports are going to come out in a lot of different shapes and sizes. Every lab kind of has their own format that they use for reporting results. And generally, they're going to kind of use these yield response curves to kind of determine whether or not your nutrients are deficient or excess or kind of right where they need to be. So they tend to use different categories like low, medium, or high, or optimal, suboptimal, you know, et cetera. You'll see different things from different labs, but generally these soil test curves, what they show is that if you're adding fertilizer, you're gonna, you know, initially you're gonna get crop growth and higher yields out of it, but there comes a certain point where additional fertilizer no longer actually has a benefit to the crop. The crop has taken up what it needs from the soil, and it's no longer actually utilizing any additional fertilizer that you would put on. So at that point, you're kind of wasting your money and wasting fertilizer and potentially, you know, polluting rivers and streams and things like that. So what they use are these yield response curves, which shows a certain level, a certain soil value level at which, you know, fertilizer will continue to be beneficial and at what point additional fertilizer is no longer needed. So typically if you get something in the low category, it does mean that adding fertilizer will increase growth and yield. If you get something in the high category, then that means that, you know, additional fertilizer really isn't going to do much for the crop. You're not going to get more growth, you're not going to get more yields out of it. And then something that's in the medium basically means that, yeah, you might get a little bit of a response out of the crop, but not as substantial as you would as things that are falling into that low category. So those yield response curves are essentially what soil labs use to determine whether or not your soil and whatever, you know, whether they're testing for phosphorus or potassium, whether it falls into the low, medium, or high category. And all this is really based on research. So as I noted, soil reports are going to use different formats. Some of them use things like low, optimum, or high. Some of them are just going to give you the values. You know, you have 100 parts per million of potassium, for example. You know, your soil pH is 6.5, and you know those they're just going to give you kind of the numerical values or use an index number as well. And sometimes you will get them presented in some type of graphical form as well. But the lab should give you a clear definition of any terms that are used in their report. This is just an example from Kristin's PowerPoint of what a soil report might look like from the OSU Soil Health Lab, and they tend to report values. This is a report from another lab, and as you can see, it looks a little different. They use more of a graph. They have several categories, everything from very low, low, medium, high, very high, to kind of indicate at what level various nutrients are. They also give you pH. Sometimes they'll give you comments or recommendations. Every lab's different. They do those differently. It's worth asking what they base their recommendations on when you talk to the lab. And then I'll just also note that sometimes they do charge extra money for those recommendations as well. So if you don't want to have to pay extra money for those recommendations, there are other ways that you can interpret your soil test results. What we recommend and what Kristin noted in her presentation is that you seek out a nutrient management guide. Obviously, the more crop specific, the better. So OSU does have several nutrient management guides in our OSU Extension catalog. For those who are not familiar, the OSU Extension catalog is online. It's an online database of publications that are put out by Oregon State University Extension Service. They're free to download or view online. And we have one on nutrient management for blueberries. There's one on strawberries. I know there's one on hazelnuts. I think there's one for pasture grass. But if you can't find a very specific guide for a specific crop, then there's also this soil test interpretation guide, which is not crop specific, but it is at least regional specific. So regional to Oregon or the Pacific Northwest. At the bare minimum, you should seek out that soil test interpretation guide and take a look at it. I know we have some folks here from out of state and potentially outside the US tonight. So I just want to note that if you're not in Oregon, I recommend, if you're in the US, look at your local extension service. It's whatever university is running extension in your state and see what they have for soil test interpretation or nutrient management guides in your region. This is one that's just an example. This is the Growing Blueberries in Your Home Garden. It's a publication that you can find in our OSU Extension catalog. And as you can see, there's a table in it, and it's the recommended soil nutrient ranges for blueberries. And they're telling you what the deficiency level is. So they tell you, for example, for potassium, if your soil test indicates that you have less than 100 parts per million of potassium in your soil, then essentially potassium is deficient at that level. You will need to add additional potassium fertilizers that year to your crop. So that's the kind of information that you're essentially seeking out in these crop protection guides to help you interpret soil tests. So when using interpretation guides, review them before you actually send in your soil sample. I know a lot of times they'll tell you what to test for. For example, something like boron, that's, as I noted, it's really important for like nut fill and hazelnuts. So that's something that's noted in the hazelnut nutrient management guide, is that we do recommend testing for boron. It may also recommend, what depth to test at. Obviously, typically for soil tests, you're testing like the top 6 inches of soil. That's where the roots of most crops are located. And that's where they're going to be accessing nutrients from. But if you're testing something like tree crops, then it's probably worthwhile to not only test the top 6 inches, but even the 6 to 12 inch range of soil as well. So look for a nutrient management or soil test interpretation guide before you sample and see if there's specific guidelines on how to sample and what to sample for. The other thing I'll note is once you start testing or taking soil samples, it's good to be very consistent. So you want to test kind of at the same month every year, every time you do it. So if this year you take a soil sample in March to send into a laboratory, 3 years from now, when you go to take another soil sample, take it in March. Again, that way the results are comparable between years. Same with the depth. If you're testing the top 6 inches of soil, then do that again the next time. And then hold on to these tests. It's interesting to go back and look how things change over time. And it'll be good for your records to kind of know what kind of changes or improvements in soil health that you're seeing in your garden. What I'm going to go through tonight is more based on this soil test interpretation guide, which again, you can find in the OSU Extension catalog. Its code is EC1478. It's really applicable for the Pacific Northwest. Most of the interpretations are based on kind of that scale of low, medium, high, or excessive. But again, you can find more specific information in really regional or crop specific nutrient management guides. But this is a good general guide. I know a lot of you as home gardeners, you aren't just growing strawberries or you aren't growing 10 acres of hazelnuts. So sometimes those crop specific guides maybe aren't as useful for you. You have a very mixed vegetable garden or maybe a landscape or something like that. And in that case, the soil test interpret guide is sufficient for what your needs are. But basically nitrogen, as I noted, soil testing, it can be really difficult to predict, nitrogen levels in soil, partly because nitrogen is, there's the whole nitrogen cycle. So the state of nitrogen is constantly changing the soil. Nitrates are easily leached out of the soil. If you're, testing in or right after the season, you could have applied some fertilizer that will, skew the test results a little bit. So nitrogen is something that we don't necessarily recommend that you base your nitrogen fertilizer applications based on soil tests. What we recommend is that you base your fertilizer application based on recommendations in, again, crop management guides. So that's generally what you're going to use to determine how much nitrogen you should apply to a soil. I will note that there are some cropping systems where we recommend taking a post-harvest nitrate test. So sometimes between like September 1st and October 15th, and that can kind of tell you whether or not you applied too much fertilizer in your soil and whether or not you have excess nitrates left over at the end of the cropping season. But this is kind of an example when I say, you know, base your nitrogen application based on crop recommendations. Here's the Soil Fertility and Organic Systems, a guide for gardeners and small acreage farmers. Again, this is a publication you can download or view online in the OSU Extension catalog. And what they're telling you are what the nitrogen requirements are for various vegetable crops. So, you know, things like baby greens and cucumbers and radishes, they only need about 3 pounds of nitrogen per 1,000 square feet per year. Whereas you have other crops that have much higher demands for nitrogen, something like broccoli, typically your brassicas, so broccoli, cabbage, cauliflower, things like potatoes and celery, they're going to need as much as 5 pounds of nitrogen per 1,000 square feet. So that's essentially what you're basing your nitrogen applications on. If you grow strawberries, then strawberries need about 110 pounds of nitrogen per acre per year. And that's essentially what you have to apply over the course of the growing season to meet the crop needs. I'll also notice that a lot of these guides will also tell you when to apply. So, you know, there's only certain times of year where those fertilizers are actually useful to the crop. So make sure that you're applying fertilizers at the right time of year as well. So if you're testing for phosphorus here in Western Oregon, we recommend the Bray test. That's typically what's used for acid soils or neutral pH soils. If you're in Eastern Oregon, then you'll want to recommend the Olson test. But what you'll see in this soil interpretation guide is that table that you see at the bottom of the screen. And that's basically telling you, you know, if you get a Bray test, a Bray phosphorus test, and it comes back and it tells you you have 30 parts per million of phosphorus in your soil, then you can look at this and be like, okay, Bray test, 30 parts per million, that puts it in the medium category. And then on the right, they give you a recommendation. So they're saying, okay, if you fall between 20 and 40 parts per million phosphorus, then you need to apply 0 to 200 pounds phosphate per acre per year. That's obviously a huge range. And so you'll have to kind of interpret within that range, you know, whether you want to apply 100 or 200 pounds of phosphorus fertilizer. And then I'll also note, obviously, as a home gardener, you're going to have to convert this into square feet, unless, you know, you have a really large home garden and you're growing on an acre or something like that. Potassium, you generally don't want the values to fall below 100. Usually, if you're below 100, then you're going to be at the low or deficient level. And once potassium is deficient, then that can really reduce plant growth. So once again, there's a table in the guide that's going to kind of tell you if you have less than 150 parts per million, then you're low or near deficient in potassium, and you need to apply about 100 to 300 pounds of some type of potassium fertilizer per acre in order to correct that deficiency and give the plants what they're going to need to complete their growth and life cycle and put out a good yield. Magnesium, you typically want between 100 and 250 parts per million, or about 12 to 18% of the base saturation. And too much magnesium can be a problem. It kind of interacts with potassium in the soil. So if you have too much magnesium, it can end up tying up the potassium, and then the potassium is no longer available to the plant. So you generally want about a 2-to-1 ratio of magnesium to potassium in your soil test. And I'll also just note that if you do have a magnesium deficiency and you also have a low pH and you need to lime the soil to raise the pH, then use dolomitic lime, because that will not only provide the lime needed to raise the pH of the soil, but you're also going to get the magnesium out of the dolomite as well. Calcium, you typically want between 1,500 and 2,000 parts per million or higher. You rarely see calcium deficiencies on acidic soils, and usually they aren't, generally if your pH is within range, you typically don't see a calcium deficiency in this part of the world. It's really an issue. Sulfur is another one where, like nitrates, sulfates are easily leached down to the soil. So it can be very hard here in Western Oregon to use the results of soil test and kind of correlate them to plant growth. So generally what's recommended is a plant tissue test. For if you think you have a sulfur deficiency, then a plant tissue test is going to give you a better diagnosis than a soil test will. The other thing to note about sulfur is you're probably applying sulfur, to your garden without even realizing it. Most irrigation water has sulfates in it, compost, manures, and a lot of other fertilizers, even NPK fertilizers, often have some sulfur in them as well. So oftentimes if you're using compost or manure or, even your water that you're supplying to the crops is going to provide enough sulfur for the crop needs that you don't actually have to apply additional sulfate fertilizers. Micronutrients deficiencies are kind of uncommon with the exception of boron and zinc. Those are the two that you probably need to pay the most attention to, but we generally don't recommend micronutrient testing unless you think you have a deficiency. And even if you have a deficiency, oftentimes plant tissue testing, taking leaf samples is often the best, a better, more accurate diagnostic tool. But if you think you have a deficiency, then it is worth getting either a plant tissue or a soil test. And that will kind of help you determine what rate of lime you need to apply to either raise the pH, or maybe you're trying to grow an acid-loving crop like blueberries and you need to lower the pH, then that would be sulfur. But just a note here, pH has a huge impact on the availability of nutrients in the soil, depending on where in the scale of pH you are. Just if you have a very low pH, then anywhere between like 5.0 and 6.5, generally micronutrients are sufficiently available in those pH range. It's when you get up to say 7.5 that those micronutrients might become unavailable. Okay, so soil pH, again, very important because it really impacts availability of nutrients on plants. So if you have a really acidic soil, oftentimes those macronutrients like your nitrogen, phosphorus, potassium, sulfur, those become a lot less available. It has to do with like, just kind of the microbes in the soil and their ability to kind of cycle nutrients and mineralize them, but as well as the solubility of those nutrients at different pH ranges. So you want to make sure your pH is within range, which for most crops is between 6 and 7, or even 6.2 and 6.8 is really kind of considered the optimum range for most crops. Obviously, there's some acid-loving crops that love a pH of 5.5, but the soil pH is just a measure of the acidity or the alkalinity of a soil. It ranges from 0 to 14. 7 is neutral, so things less than a pH less than 7 is going to be an acid soil. Higher than 7 is going to be an alkaline soil. And just keep in mind, this is a logarithmic scale. So for example, a pH of 5 is going to be 10 times more acidic than a soil pH of 6. So there are various ways to calculate lime needs. I'm not going to go through those tonight, but just note that this table here is kind of showing the minimum soil pH values that are recommended for crops in Western Oregon. Down at the bottom, you'll see brassicas, and as well as other assorted vegetables, and you typically want the minimum value to be around 6.5. Soil organic matter is another thing you might test for in soil. So that's kind of a good indicator of overall soil health. So typically 5% of organic matter in your soil is considered high, 1% is considered very low. So you want somewhere around 2%, 2 to 5% generally. Most agricultural soils range from 1 to 6%. Whereas non-cultivated soils, they can have as high as like 10% organic matter. So things like our forest soils, where you just have all that leaf litter and everything falling to the forest floor, all that decomposes over time and essentially turns into organic matter. And because, since we aren't cultivating those soils, that organic matter kind of stays in place, and you end up with much higher organic matter content in those types of soils than you do in an agricultural soil. So some general management recommendations for Western Oregon. So make sure your pH is within range. Most likely, most soils here tend to be acidic, so likely you're going to be applying lime to raise your pH. You want to get it to about 6.5. Obviously, the exceptions for that are your acid-loving crops, things like blueberries and rhododendrons. Those are the opposite. They need an acidic soil. So if you are doing soil testing and you have, say, a vegetable garden, and then you also have an area where you're growing blueberries, you would actually want to sample those two areas separately. So you want to send in 2 soil samples, one for the vegetable garden and a separate one for the blueberry area, because they have different requirements in terms of pH. Use fertilizers or compost to supply your macronutrients, such as phosphorus, potassium, sulfur, and any micronutrients that may be needed as well. Apply nitrogen fertilizers based on crop demand. So again, that's not necessarily looking at a soil test, but following what's recommended in crop production guides. If you're using cover crops, like a legume cover crop, you can reduce your nitrogen fertilizer, application the following year. And the same could be said if you're using high amounts of compost or fertilizing regularly. You can reduce kind of those fertilizer requirements that are mentioned in the guides. And OSU actually has a publication on calculating how much nitrogen you're getting from your cover crop. It's an interesting publication. There's a lab that can actually test for you how much nitrogen you're getting from it as well. But most home gardeners, that's kind of above and beyond what's really needed for gardening in your backyard. So just note that if you are using cover crops or a lot of compost, your soil probably has quite a bit of nitrogen and probably even phosphorus and some other things in it. You can kind of reduce, the nitrogen needs, fertilizer needs based on that. So again, look for some good interpretation guides. There's the soil test interpretation guide. There's some more crop specific ones, like growing blueberries in the home garden has some good information, as does this soil fertility guide that's mentioned there in the middle, and that should help you interpret the results from your soil test. I also want to note that here in Lane County, our Master Gardener program, we do offer soil pH testing. For $2 per soil sample, we will test the pH of your soil and send you the results, and kind of help you understand what you need to do in order to get the pH within range. It's $2 per sample. So we do have another testing day here in April in Eugene, and we're planning for testing days May 7th in Florence and Oak Ridge as well. And you can find more information about this by going to the OSU Extension Lane County website and then clicking on our events calendar, and you'll see that the soil testing day for April 2nd is already listed there. Do read that information. We have a good handout within that event calendar on how to take a soil sample, as well as more information on the times that we'll be collecting soil samples, the location, the cost, etc. So do take a look at that if you're interested in getting soil pH testing done for your home garden. And with that, thank you for your time this evening, and we will go ahead and open up to questions. Thank you.
So just before we start the questions, I'd like to mention that when you leave the seminar tonight, you'll be asked to fill out a short evaluation. So filling out the evaluation will give us valuable information to help us improve what we're doing. So if you have a question, please type it in the Q&A box, and we'll be sure to answer it for you. Here's Erica already put, what is a natural lime one could use? She already answered that one with
Let's use limestone.
Okay. Do either one of you know of any free soil testing opportunities for low-income people?
I'm not, but again, those soil pH testing days, they're $2 per sample. That's probably about the best deal you're going to get. And pH is going to tell you a lot. So if you're low income, I recommend checking out our soil pH testing days here in Lane County. I think other counties offer it here in Oregon as well. So if you're not in Lane County, check out what your local extension office is doing. But I'm not aware of any free testing. And I'll also say, Kristin had the analytical labs for Western Oregon. It's a publication, and it'll tell you all the labs that service Western Oregon. And every lab has different price schemes. So definitely dig around and see what the different prices and fees are in those different labs. I know A&L Western up in Portland will do like a complete soil test for about $15. And that's probably, again, about as cheap as you're going to find it. So yeah, just check out the pricing and fees required for those different labs.
Are store-bought test kits of any use?
I want to let Kristin answer this one because I've certainly answered it enough, but I'd like to hear her thoughts on this.
Unmute, sorry. That's a tricky question to answer because it varies too much. So I suppose if you're doing interpretation, it's just better to maybe have more clarity by getting in a lab analysis. I think it varies too much for me to say for certain that home kits are a good option. I guess, Erica, I'm not sure what you've said on that subject, but I don't have too much to offer on that.
Yeah, I generally say it varies depending on the home testing kit. I used to teach at a community college, and we used the Willamette home testing kits for a lab we did. So I'd break the students into different groups, and they'd all have the same Willamette testing kit. And I can tell you, every single group got different results. Now, some of that was based on how carefully they read instructions, but it just also showed a little bit that there's a lot of variability within those home testing kits. So, and Lamott's kind of considered one of the higher end, better brands or better marks as well. So just, keep that in mind. But, if limited, they aren't the worst things in the world. I think, you'll get at least kind of a general understanding of what's going on in your soil.
Okay, we make soap. Can we use our soap pH testers for testing our soil?
I don't know what's used for soap making, honestly, so I can't answer that. Kristin, do you know the answer to that?
I don't have experience with that, but soap making sounds fun.
Yeah.
This one says test of communication via chemicals between plants.
We don't offer a test. I guess your communication via chemicals between plants, that would be a little bit more detailed than what we offer. Yeah, but will be interesting.
Okay. Are there any other questions out there? We are a little bit past time, so maybe we'll close it up for the evening. And thanks to both of you, the excellent talk. I enjoyed it very much. So thank you. Thank you, everyone.
Thanks, Kristin, for joining us.
Thanks.